8.3, the quadratic relation, y equals ax squared plus c. So for a quadratic relation of this form, y equals ax squared plus c, the maximum or the minimum value occurs at c, which is like this value right here, when, again, like our equation is in this order, okay? And then this is the optimal value. Okay, find the max or min of each relation. Okay, so what we do here is that in this position, because we have an equation in the form y equals ax squared plus c, our optimal value or our max or min would occur at -9. Okay, and just as a recall, our a value right here, so our a value is positive. That means we open up. Okay, so then we're going to have a minimum here. Okay, the minimum is -9. Okay, I just kind of want to go back up to here. Also in this form here, the C is also our Y-intercept. And our Y-intercept. Okay, and we have that over here. For a recall, the Y-intercept here is C. Okay, it doesn't matter if it's in like completely expanded form or just this short form here. Okay, for B, y equals -2x squared plus 32. So 32 is going to be our max or our min value. Okay, and our A value is less than 0, so it's negative. So this is going to be opening down, and we're going to have a max. So our max here is 32. Okay, and y equals 3x squared. So here's the thing. Our original here is y equals ax squared plus c. Okay, so we have 3 as a, and then we have our x squared. But here's the issue. It's plus c, right? So why don't we do like, it would technically be plus 0. Okay, so our a value is greater than 0, so it's positive, so it opens up. Okay, so we're going to have a min of 0. Okay, that number right there. Okay, now find the zeros of this relation here. Y equals x squared minus 9. Okay, so as a recall for the quadratic equation of this form here, and remember this form is our factored form. Okay, our x-intercepts are R and S. So if we go ahead and factor this, so as a recall, what two numbers multiply to -9? And if you think about this in completely expanded form, we would have that 0x in the middle here because there's no x value, so it's actually 0x. Okay, and what two numbers add to 0? Well, two numbers that multiply to 9 are 3 and 3. So to add to 0, we would put a negative on 1. 3 minus 3 equals 0. So x plus 3, x minus 3. Okay, so finding the zeros, we would branch these out. X plus 3 equals 0. Bring that over. X equals -3. Okay, and then x minus 3 equals 0. Bring that over. X equals 3. Okay, example 3. A ball is dropped from a building and its path is represented by this relation here. Okay, so again, this is still in the form y equals ax squared plus c. The only difference is that we are using h and t instead of x and y. Okay, so where a represents the height of the ball in meters and t represents the time in seconds taken for the ball to fall to the ground. Okay, so from what height was the ball dropped? Okay, this is going to be our y-intercept. Okay, so to actually find a y-intercept, we can pull it straight out of the expanded form, which is a fine way to do it. Okay, so that goes away, and we have h equals 100. So therefore, the ball was dropped from a height, so from 100 meters. Okay, and then what is the height of the ball after 5 seconds? So when you talk about seconds, we talk about time, right? We're not we're going to actually try to find the height, but we're going to sub in 5 for the time. Okay. And our height that we get is actually negative 25. But if you think about a ball being dropped from 100 meters and falling on the ground, okay, let's see this in another color, falling on the ground, we're not going to go through the ground to negative 25. That's not going to make sense. Okay, it's going to land on the ground, maybe it's going to bounce a couple times, and then it's just going to lay there flat. Okay, so what we would say is, therefore, the ball falls to the ground. And okay, let's go at 0 meters high, right? Because technically it's asking what's the height. So the height is 0 meters, and it just falls to the ground. Okay, example 4, the graph of the quadratic relation, so this one right here, and if you notice we don't know what the a value is, so we have y equals ax squared minus 20. Okay, it passes through the point 2, 4, which is our x and y. Okay, so find the value of a. So we don't know what a is, but we have 2 and 4, so we can sub 2 in exactly where this x value is. Okay, leave the a. And we're going to sub in the 4 exactly where that y value is. Okay, so 2 squared is 4, 4a minus 20. Okay, we're going to bring this negative 20 over. 4 plus 20 equals 4a. So we get 24 equals 4a, and then we're going to divide out that 4. So in this case, a equals 6. Okay, so this is strictly sub these two numbers in and solve. Okay, example 5, very similar. The graph of the quadratic relation is this. So we have y equals negative 4x squared plus c. Okay, this time it's clear that we don't have the c value. And this graph passes through the point x comma y. Find the value of c. So we're going to sub in negative 2 for our x, which is right here. We're going to sub in negative 1 for our y. We're going to bring down that negative 4, bring that down, that plus c. Okay, so negative 1 equals negative 4. So negative 2 squared is 4. And then negative 4 times 4 is negative 16. Okay, bring that over. We get negative 1 plus 16 equals c, which is 15. Okay, and then that's it. Find the value of c. C equals 15.